Hello students, how are you all? I hope you are doing amazing. So welcome all of you at AriserTalent, and I'm your physics teacher Krina welcomes you all. So we were discussing about the magnetic effect of electric current, and in our last session we have a very good discussion about the electric generators and motors. Now in today's lecture we are going to deal with some of the NCERT questions that are related to your Class 10th magnetic effect of electric current. So let's discuss some of the questions that are related to your chapter, that is magnetic effect of electric current. So let's move to the first question. Now what the first question is saying, which of the following correctly describes the magnetic field near a long straight wire? So in case of a long straight wire, the magnetic field always exists in the form of the concentric circles. So the field consists of a straight line is perpendicular to the wire. So this will not be the correct option because it is not describing the magnetic effect due to the long circular conductor. The field consists of straight lines parallel to the wire. This is again absolutely wrong statement because this will not be parallel to the wire. The field consists of radial lines originating from the wire. Actually, these are not the radial lines. These lines for the straight conductor will be in the form of the concentric circles only. So this will again be the wrong statement. The field consists of concentric circles centered on the wire. So the field due to the long straight wire will be the concentric circle, and they have their center only on the wire. So which will be the correct statement? Here we can see that option number D is correct according to the long straight conductor. So our option number D will be correct here. Now let's move to the next question we have. The phenomena of electromagnetic induction is. So I have told you that the electromagnetic induction is a very important phenomena. So in electromagnetic induction, basically what happened, there is a relative motion between the coil and the magnet, and due to which the induced EMF is generated. So you have to choose the correct definition of electromagnetic induction, that is our EMI. So first option is EMI is a process of charging a body. So this will be the false statement. This is not a process of charging any body. Process of generating magnetic field due to the current passing through the coil. It is not the process of generating magnetic field. Instead, it is the process of generating induced EMF or current in the circuit. So again, this statement is absolutely false. Now, producing induced current in a coil due to the relative motion between magnet and coil. So if there is a relative motion between magnet and coil, then there will be the induced current or EMF in the circuit, and this will be the definition of electromagnetic induction. So we can say that our option number C will be correct in this case, but you do not have to choose only options by reading 3 statements. We have to see the 4th statement as well. Process of rotating the coil of an electric motor. So it is not the process of rotating the coil in an electric motor. So I can say that option number C is correct. So this is in accordance with the definition of electromagnetic induction we have. So this is again a theory question we have. Now let's move to the next question in this sequence. The device used for producing electric current is. Now, you have to find out the device which is used for producing electric current. Now, device used for electric current is generator, galvanometer, ammeter or motor. So, the generator is a device which is used for producing the electric current, because galvanometer and ammeter are only devices which is used to detect the current. They are not used to generate any current. So I can say that generator will be the correct option in this. Don't get confused between other 2 options, because galvanometer and ammeter is actually used to detect current. They are used to detect the current. They are not used to going for producing any kind of current. So generator is a device and motor is again our wrong option. So generator is a device which is used for producing the electric current. So our option number A will be correct here. Now Moving to the next question we have. The essential difference between AC and DC generator is. So in this chapter, we have seen two important devices, that is about the AC and DC generator. We have also gone through the construction and working of both the devices. So what actually there is a difference between AC and DC. In between AC and DC, there is only one difference, and this difference is only due to the slip rings, that is the commutator present in that circuit. So basically, there is one difference, and this difference will be due to the split rings. So let's check the options. What options are saying? AC generator has an electromagnet while DC generator has a permanent magnet. This is absolutely wrong, because these both consist of two strong electromagnets in which a shaft is, in which we can say that the spindle or shaft is rotated between them. DC generator will generate high voltage. This is again a wrong statement. AC generator will generate a high voltage. This will not be true. AC generator has a slip rings while the DC generator has a commutator. So it is the only difference that is due to the slip rings, or we can say that the split rings, because in this DC generator we have seen, we have the two half rings present there. In this generator, we have two half rings, but which are called commutator. But in case of the AC generator, we have a single ring that is known as the slip ring. So this is the basic difference between AC and DC. So I must say that option number D will be the correct option here. So you can note out this question from here, because these questions are from your NCERT, and these questions are very important from your CBSE point of view. Now, let's see the next question. At the time of short circuit, the current in the circuit. So what actually happens in the case of the short circuit, when two naked wires come in contact with each other, they will going to generate the high current. It means the current is going to produce very abruptly in the circuit. So what will happen in case of the short circuit, the current is going to be increased. So let us see the options here. Reduces substantially, does not change, increase heavily, vary continuously. So the correct option will be option number C, because the current is increasing very abruptly. That's why the short circuit is occur. This is a very common term you have heard in your houses, that many of the devices have the short circuit in them because the two wires come in contact with each other. So why the short circuit occur? It basically occurs because of the increase in the current in the circuit. So here the correct option is increasing heavily. This is a very simple question we have. Now, let's see what the next question is saying. State whether the following statements are true or false. So, we have to identify the true or false statement among all these questions. So, I am reading the first question here. An electric motor converts mechanical energy into electrical energy. So, this is a very simple question, that electric motor is used to convert electrical energy into mechanical energy, and generator is used to convert the mechanical energy into electric energy. So, electric motor is actually a device which is going to convert electrical energy into mechanical energy. It is going to convert electrical into mechanical, not mechanical into electrical. So I can say that this will be your false statement. So this will be our false statement. Now, let's move to the next question in this series. An electric generator works on the principle of electromagnetic induction. So again, this is a very simple question. All the devices we have discussed till now usually work on the electromagnetic induction. When there is a relative motion between magnet and coil, there will be the induced current in the circuit. So again, this device is working on the electromagnetic induction. So this is our true statement. Now, let's see the third question we have. The field at the center of a long circular coil current carrying will be parallel straight lines. So, in case of the long circular coil, you will get the current carrying line will be the parallel straight line. So, in the center we will get the parallel lines, but in the corners we will get the circles of different radii. The current carrying conductor or the current carrying circular coil we have discussed in our chapter that the current produced and the magnetic line produced in this coil will have a straight lines at the center and circles at the corners only. So this statement is again true. It will be the long parallel straight lines. Now, a wire with the green insulation is the live wire of an electric supply. The live wire will never be made of the green color. The live wire will always be of the red color and the earth wire will be our green color. So this statement is again false because we have the 3 wires in the circuit. So the live wire will be of the red color and that earth wire will be of the green color. So you have to remember the color coding of the wires because it is very essential to learn all the color codings. So this is a questions that is related to your true and false. So let's move to the next question we have. List 3 sources of magnetic field. So, you have to identify the sources which are going to produce the electric field. So, electric field is basically produced by electromagnet. Magnetic field lines is produced by the electromagnet, permanent magnets and current carrying conductor also going to produce the magnetic field. So, I can write the 3 sources here will be. First one is electromagnets. Second one is permanent magnets. And the third one will be current carrying conductor. So, these are the 3 sources according to which we can develop the magnetic field lines. So, these are the basic sources for the magnetic field lines. These are very simple questions from your NCERT, but these questions are not going to become in your competitive exam because these are only up to the level that is our CBSE has decided. Now, let's see what the next question is saying. So, how does the solenoid behave like a magnet? So, solenoid will behave as a magnet because solenoid is having a circular loops. So, this is what the solenoid we have. These are having a number of turns. So, this is what the solenoid is. It is having a circular loops and the number of turns are wounded on a copper wire we have. So, this is the solenoid we have. So, whenever a current is passed through this solenoid, it will create a magnetic field around it and the magnetic field produced by the solenoid will exactly the same as that of the bar magnet. So, if I'm going to draw the magnetic field lines due to the solenoid, what I will get here? I will get somewhat like this. So this is how the bar solenoid will look like a bar magnet whenever a current is passed through it. So whenever a current is passed through a solenoid, so the current carrying solenoid will going to produce these magnetic field lines, and these are exactly same as that of the bar magnet we have. So this is how when a current is passed through the solenoid, it will going to behave like a magnet. So this will be the first question we have. So what will be the answer for the first question? A current carrying solenoid will behave as a bar magnet because it is showing the magnetic field lines similar to that of the bar magnet. Now, the second question is saying, can you determine the north and south pole of a current carrying solenoid? If I have to determine the north and south pole of this current carrying solenoid, what I have to do? I have to bring the bar magnet closer to it. If I am considering this is our bar magnet, it is having north pole and it is having south pole. If I am bringing this bar magnet to the negative terminal of a battery, if I am bringing this bar magnet to the negative terminal of a battery, it will going to repel each other, because we know that the like poles always repel each other. So what will happen if it is bring if this bar magnet is brought near the negative terminal of a battery, they are going to repel each other. And if they are repelling each other, we can say that they are the like poles. So I must conclude that the north pole will be the negative terminal and the south pole will be the positive terminal, because these are going to attract each other. They are repelling in the first case. We know that the like poles always repel each other. So we can conclude that the north pole will be the negative terminal and the south pole will be the positive terminal of a battery. So this is how you can conclude that how you will identify the poles in case of the solenoid. So when you brought the bar magnet near the solenoid, you will see that the negative terminal is always going to repel the north pole. It means they are the like poles which are repelling each other. So I can say that the south pole will be our positive terminal and the north pole will be our negative terminal. So this is a very interesting question we have, and this type of the question can be asked because the solenoid is again a very important topic from our chapter. Now let's move to the next question in this series we have. When is the force experienced by a current carrying conductor placed in a magnetic field largest? So, if you want to determine when will be the force maximum in a current carrying conductor, you have to remember only one simple formula, that is Bill sin theta. So, force experienced by a current carrying conductor and this force will be given by the formula, that is our Bill sin theta. So this will be the formula for calculating the force due to current carrying conductor. And if you remember the sin theta cos theta trigonometric table, you know that the value of sin 90 will be maximum, because sin 90 will give you the value that is 1. So I can put theta equal to 90 degree. So what I will get here, F is equal to BIL sin 90, and sin 90 will be equal to over 1. This is equal to 1. So what I will get here, I will get F equal to BIL. So this will be the maximum value of the force, that is the largest value of the force. So when will be the force experienced by a current carrying conductor in a magnetic field is largest? When the coil and the magnet are perpendicular to each other. It means if they are perpendicular to each other, they are going to make an angle of 90 degree. So I can say that when both are perpendicular to each other, the force will be the maximum, and that will be equal to the sin 90 value, and sin 90 will give you the one answer. So F equal to BIL is the largest value of the magnetic field here. So this is again a very logical question you have. Now let's move to the next question in this sequence we have. Imagine that you are sitting in a chamber with your back to one wall. So this is a question in which you have to find out the direction of the magnetic field. This type of the questions we have also discussed in our previous session, but again we have one more question. So let's see what the question is saying. You are sitting in a chamber with you back to one wall. It means your back is in the wall and you are sitting in a chamber with your back to one wall. Now, an electron beam moving horizontally from the back wall towards the front wall. This is my back wall and I am sitting in the chamber with my back to the wall. And what will happen? Electron beam is coming from back towards the front wall. So, firstly what you have to do, just write the statements what they are saying. Electron beam coming from back towards the front. So, electron beam is coming from back towards front. Now, it is deflected by the strong magnetic field to your right side, and the deflection of the magnetic field is in the right side. So, we can also conclude one more point, that magnetic field is in right side. Now, what will be the direction of the magnetic field? You have to identify that. Now, the question is saying that the electron beam is coming from back to front. So, if the electron beam is coming from back to front, what will be the direction of the current? The direction of the current will be just opposite to that of the electron beam. So, the direction of the current will be from front to back. So, I can write here, direction of current will be from front to back. Now, what you have to identify? You have to identify the direction of magnetic field, and this can be identified only with the use of the Fleming's left hand rule. So, what does the Fleming's left hand rule states? Fleming's left hand rule says that if you keep the three fingers, that is the thumb, forefinger and the middle finger, mutually perpendicular to each other, then the middle finger will give you the field lines, this will give you the direction of the current, and thumb will give you the direction of the force. So, what I have to do? You can see that the electron beam is coming from back towards front and the current is going from front towards back. So, if I am comparing the front towards back, I can see that this finger is going to show me the direction of the current, so I can keep it inwards. If this will be the direction of current and I can apply here the Fleming's left hand rule, this will be the direction of current, that is from front to back. Now, you can see that the deflection of a strong magnetic field to your right side. This deflection will be in your right side. So, you have to just visualize yourself because it is a bit difficult to show it by using my fingers. So, just analyze it by comparing it with your fingers. So, this will be the direction of current. This will going to give you the direction of the induced current or EMF in the circuit, and or we can say that the force, and this will going to give you the direction of the magnetic field. So if I keep rotating my fingers in this manner, I can see that if my all three fingers are mutually perpendicular to each other, it means this magnetic field is going to give you the direction that is inwards, and it will be the in downward direction, and it will be the inside the wall. So what will be the direction of magnetic field? The direction of the magnetic field will be inside the wall, and it will be in the downward direction. So the direction of the magnetic field will be downward and it is slightly inward. And how you will identify that? We can identify it only by using the Fleming's left hand rule. So this is how the Fleming's left hand rule work, and this question is very important, because these type of the questions will usually asked in your competitive exam, because they are conceptual questions we have. Now let's see what next question is saying. Draw a label diagram of the electric motor. Explain its principle and working, and what is the function of split ring in an electric motor. So this question we have discussed in our previous session, that what will be the diagram for electric motor and what principle and operation they are working on. So you can see that lecture for this particular type of the question, because this is our long type answer questions, because in case of the electric motor, AC generator and DC generator, we have to write the whole description, according to which firstly we have to write the principle, secondly we have to write the construction, thirdly its label diagram, then its working, and what will be the function of the split rings or the slip rings in an electric motor. So this is a theoretical question we have. Now moving to our next question. Name some devices in which the electric motors are used. Again, this is a very simple question. You can only found these devices from your environment only. In many devices in our household articles, we are using electric motors. So starting from the, I can say that washing machine. Washing machine have an electric motor in it. Mixer grinder will have an electric motor in it. Cooler will have an electric motor in it. And there are so many devices which are usually working with the electric motor. So many of the devices in your household articles are actually having the electric motors installed in them. So few of the devices I can write here. First one is washing machine. Second one is cooler you have. Third one is mixer grinder. So these are the few of the devices from our household articles that are actually having the electric motors in them. You can write the other options also in this answer. So this is a very simple question you have. Now let's move to the next question in this sequence we have. A coil of insulated copper wire is connected to a galvanometer. What will happen if you push the bar magnet into the coil? So what will happen if you push the bar magnet into the coil? Then if the bar magnet is pushed into the coil of an insulated copper wire, then momentarily the galvanometer will going to deflect in the particular direction. Because you are pushing the magnet into the coil, then momentarily the galvanometer will show a bit deflection in a particular direction. So in this case, what actually happens? Galvanometer shows deflection in particular direction. Now, this is what when the bar magnet is pushed into the coil. Now, what is the second case saying? Withdrawn from inside the coil. You are just withdrawing the bar magnet from the coil. Then again the galvanometer will going to show you a bit deflection, and that deflection will be the opposite direction as that of the previous case. So, what will happen in the next case? When again the galvanometer is going to show you the deflection. But in opposite direction. So, this is the case that is just opposite to that of the previous case we have. Now, what is the third case saying? When you held the bar magnet stationary inside the coil. If the bar magnet is kept stationary inside the coil, then there will be the no deflection in the galvanometer because there will be no current passing through the coil. So, in the third case, if you held the coil stationary in the field and if the bar magnet is held stationary inside the coil, no deflection will be shown by galvanometer. So, this will be our third part. So, if firstly the coil, the bar magnet is pushed into the coil, the galvanometer is going to show you a deflection in a particular direction. When you withdraw the bar magnet from the coil, it will just show the deflection in the opposite direction. And in the third case, when you held the bar magnet stationary in the coil, it means it will be stationary and it will going to show you no deflection. So, in third case, we will not get any deflection in the galvanometer. So, again, this is a conceptual question you have from your NCERT. Just copy this from here so we can proceed to the next one we have. Now, let's move to the next question in this sequence we have. Next question is saying, two circular coils A and B are placed close to each other. So, let me rub the board for you so we can solve our next question. What you have two circular coils A and B. These both are, we have circular coils. Now, these are placed close to each other, but if the current in the coil A is changed, will some current be induced in the coil B? You have to give the reason for this. If I am going to change the current in the coil 1, if you are going to change the current in the first coil, then the magnetic field will be definitely going to induce in the second coil. This is in accordance with the electromagnetic induction we have just discussed, because if these two coils are placed close to each other, then if there is a current change in the first coil, then the magnetic field associated with the second coil will also be going to change and there will be the same current flowing in that circuit, and this is in accordance with the electromagnetic induction. So, in case of B, we have a change in the magnetic field and if that magnetic field change, we will also get the induced current in B. And this is whole concept will be according to electromagnetic induction. So again, this is a very interesting question you have. You have to just remember one point: when you place two circular coils or any two coils close to each other, if there is a current flowing in the first coil, then it will induce the current in the second coil because the magnetic field associated with the second coil changes. And this is in accordance with our electromagnetic induction. Now, let's see what the next question is saying. State the rule to determine the direction of. So you have given a 3 cases and you have to identify the rules which are going to tell you about the direction of the current or magnetic field in the circuit. Again, this is a very interesting question because I know you will be bit confused when you're going to apply all the 3 rules. You will say that in ma'am, which will we apply the Fleming's left hand rule, and in which question we will apply the Fleming's right hand rule. So we will sort this problem for you. In which case you have to apply the particular rule, I will tell you now, and this will be a very good question because maximum of the students have the same doubt that which rule we have to apply here. So what the first question is here. State the rule to determine the magnetic field produced around a straight conductor carrying current. So in the first case, we have given a straight current carrying conductor. In that straight current carrying conductor, we have only one rule that is known as Maxwell's right hand thumb rule. You will apply in case of the current carrying conductor only. So you have to remember this point. We will apply the Maxwell's right hand thumb rule. So you have to just remember the word. If the current carrying conductor is given, you have to apply the Maxwell's right hand thumb rule. Now, force experienced by the current carrying conductor placed in a magnetic field which is perpendicular to it. Again, you have to determine, in this case, you have to determine the direction of the magnetic field just by having a straight conductor. Now, in this system, in second part, you have to determine the force experienced by the conductor, but it is placed perpendicular. It is placed in a magnetic field that is perpendicular to it. So, in this case, what you have to do, you have to apply the Fleming's left hand rule. So, what we will do in the second part? In second part, again we are having a straight conductor. And what you have to determine? You have to determine the direction of force here. And it is placed in a magnetic field which is perpendicular. So, for this case, we will just apply the Fleming's left hand rule. So, we will apply the Fleming's left hand rule for calculating the force due to a current carrying conductor placed in a magnetic field perpendicularly. Now, current induced in a coil due to its rotation in a magnetic field. Now, you have to identify the direction of the current and it is rotating in the magnetic field. So, we are left with only one rule that is known as the Fleming's right hand rule. So, what we will do here, in third case, we have a current in coil and it is rotating in magnetic field. So, what you will do, you will just apply Fleming's right hand rule. So, these are the 3 cases and these are the 3 solutions which will clear all your misconception that where we have to apply the left hand rule, where we have to apply the right hand rule and where we have to use the thumb rule. So, what will happen in the first case, you have to calculate the direction for B, that is your magnetic field. In the second case, you have to find out the direction of force, so it is the Fleming's left hand rule. And in the third case, you have to find out the direction of current. So we are using the Fleming's right hand rule, and in this the coil is rotating in the magnetic field. So just remember these points because this will be helpful for finding out the direction in every question, and the question in your exam will definitely be asked from the part that is the identify the direction of the either current, force or magnetic field. So just remember these points and solve every question very clearly so you can find out the direction from these questions. So just copy this part from here. Now, moving to our next question. Explain the principle and working of the electric generator by drawing a label diagram and what is the function of the brushes. Again, this will be your theoretical question, and the working of AC generator, DC generator and electric motor, you have to understand every point very deeply, and I'm again repeating in this type of the question. Firstly, you have to write the principle, then after construction, then after draw its diagram and explain the working, and if there are some extra questions given like explain the function of the split ring or the brushes, you have to also mention that part also. So this is your question from your theory part. So we have a discussion about this question in our previous lectures, so go through these lectures also. Now let's move to the next question in this sequence. When does the electric short circuit occur? Earlier we have discussed that when an excessive current flows in the circuit, there will be a condition of short circuit. So what will actually happen here? We can see that when you connect a lot of devices to a single socket, and if we are using a very high devices in a very low voltage rating, suppose we are using the refrigerator at your home, you are using the air conditioner at your home, and you are at the same time or the simultaneously you are using the washing machine also. So if too many electrical devices or too many electronic appliances are used, then there will be a condition in which the resistance become too low and excessive current will going to pass through the circuit, and at this condition we have a electric short circuit occur. So what will happen? There are the two reasons that when resistance become low, high electric current will going to be flow in the circuit. It means the current will be abruptly increases in the circuit because too many electrical appliances are working. And in the second case, what we have, the short circuit usually occurs when the live and the neutral wires come in contact with each other. So if they come in contact with each other, they will cause a main condition that is known as the electric short circuit. So the second case will be our live and neutral wire touch each other. So these are the two conditions in which the electric short circuit usually occurs. First one is when the resistance become too low, the excessive current will going to be flow in the circuit, and in that case the live and the neutral wire in the circuit come in the close contact with each other. So this is the question that is based on your electric short circuit. Now let's see the next question in this sequence. This is our last question, and again the question is saying that is based on the earth wire or the live wire or the neutral wire concept. What is the function of the earth wire and why it is necessary to earth the metallic appliances? So the role of the earth wire in the electronic circuits or in the electric appliances is very, very important. So what you have to do, we have to connect the earth wire to the metallic part of the appliances we are using. So what will happen in this case, if excessive current passed in the circuit, then through this metallic device, this current will directly go to the ground. And if this current is going to the ground, it will not cause any harm to us, or it will not cause the condition of the electric short circuit here. That's why the earth wire is usually provided with the devices, so the excessive current will flow to the ground only, and this will be attached to the metallic part of the appliances we are using, because it will provide the insulation to that devices. So this is how the earth wire basically works. So I hope these questions are clear to you. For many such lectures or for many more lectures and for solving all the type of the questions we are discussing here, just subscribe our channel. Go through each video lecture very clearly so the concepts are clear in your mind. And in our doubt session, you can just post your problems and we are available to you 24/7. So I'm ending this lecture here. Thank you so much and have a nice day.